Good morning. Are you able to hear me?
Yes, sir.
Yes, Om.
Okay. Okay. Let's start our today's session. I don't take much of your time today, so we'll finish the session soon. Okay. So I have two concepts remaining in BigQuery, so I just want to cover them up. Let me share my screen. Are you able to see my screen?
Yes, sir.
Okay. So fine. Today we will discuss about a few important concepts in BigQuery. So those are UDFs, user-defined functions, okay, and materialized views, okay. So materialized views and normal views, okay. Views. So under views concept, we'll discuss what are views and what are materialized views and how different these two are, right? Okay. So we'll discuss these two concepts today. Okay. So first we will focus on UDFs. Okay. So what are UDFs? Why we need UDFs? Right. So how to create UDF in BigQuery and how to call the UDF in BigQuery. Right. So let us quickly see how actually what is UDF. Okay, so you in real time you may get scenarios wherein some use cases you won't be able to achieve that use case with normal SQL inbuilt functions that you have, right? So in that scenarios you may need to write user defined functions, some kind of custom logic that is needed for the requirement, right? So in that scenarios, you will use these user-defined functions. These user-defined functions are can be written in two languages. One is SQL, another one is JavaScript. So BigQuery will support JavaScript-based UDFs. Okay, but Python UDFs also BigQuery will support. But right now, at the moment, Python UDFs are at beta stage, so they did not released the Python UDFs yet. But as of now, two languages BigQuery will support for writing UDFs is SQL and JavaScript. Okay, so we'll see both of them, how we can write UDFs, user-defined functions in SQL, how we can write user-defined functions in JavaScript. So we'll see both of them. But remember, when we are using UDFs always reduces the performance. Be very, very clear on it. Okay, until unless it is very much required and you are not able to achieve it with your queries, right? So then in that scenario you will try to go for UDFs. So that is why in real time we hardly see UDFs. Okay, we hardly see UDFs. So but if it is a SQL UDF, then it won't impact much. But if it is a JavaScript based UDF, it, there will be a lot of serialization involved. So obviously the performance of JavaScript UDF will be a little bit slow, right? So I recommend not to go for UDFs. I mean, until and unless it is very much needed. Okay, so that is about UDFs. So UDFs meaning user defined functions. Okay, user defined functions. So these functions can be used when we have a complex logic involved, which we cannot achieve with normal inbuilt SQL functions. Okay, so this can be written in SQL or JavaScript. Okay, so these two languages will be supported by the UDF, and UDFs are a little bit bottlenecks for performance. Okay, so now let us see how we can create UDF, right? So in a normal things, right? So here, let us take an example. I have a table that got created, right, which is sample UDF. Okay, and here, if you see, I'm creating a function. So this is the syntax for creating SQL based UDF, right? So here if you see create or replace function, and I'm just creating that function in under my data set. My function name is area, and this will take two inputs. One is length and then width. This is how you will specify the input parameters. So length and width. Okay, so two inputs of a float data type, and returns a float data type. So you need to specify the input parameters and the return parameters to your function. Okay, so create or replace function, your function name, and then your input parameters, and then your output return type. Okay, as is the parameter that you need to give to specify the actual logic, right? So I'm just multiplying length into width, so it will simply do the multiplication of these two, and then it will return. Okay, so this is how you will create a simple UDF. Okay, and this is in SQL, and if you want to create in Java, you can see, sorry, if you want to create in JavaScript, you can follow this kind of notation. Okay, so this sample UDF and then reverse string UDF. So this is in JavaScript. I'm just creating a reverse string UDF, which is actually taking input as a string type and then returns again a string, and the language is JavaScript. Okay, as I'm specifying, and I'm writing my JavaScript based logic inside this. Okay, JavaScript based logic inside this. So this is how you actually create UDFs, right? So and how we will call UDFs, right? So let us quickly understand how we can call UDFs in BigQuery, right? So if you see here, when you create UDFs, it will go to your routines. Okay, so here if you see, the UDFs will be, okay. So when you see the UDF, so you will see the details of this UDF. Okay, so now how you can call the UDF, right? How you can call the UDF? So simply when you have this table, right? So let me see whether I have, yeah. Select star from empdb dot sample underscore UDF. Okay, so this is my table. So when I run the query, so I have the data in my table, length, width, input, n value. Okay, so now if I want to call my UDF, you can simply go select star comma. Okay, so you need to call your UDF function, which is already in your data set, right? So you need to empdb. Okay, don't need this, maybe empdb. So what else I'll specify? So your project name dev hyphen de hyphen training dot your dataset name. Okay, and then once your dataset, your UDF. Okay, so your UDF of, you have length length comma width. Okay, you're passing these two columns from empdb dot sample underscore UDF. So this is how you will call your UDF. Okay, so in the select statement, I'm calling this UDF as I know this UDF will take two parameters. One is length and width. Okay, I'm just passing my two columns, length and width. Okay, and this UDF always generates a record, not a column. Be very clear. Okay, it's a record level operation. Okay, it's a record level operation, meaning for every record it will go and it will read the length and width values, and it will pass it to your UDF function. In the UDF function, what is the logic, right? It is length into width. Now, according to that logic, your compute will happen and it will return and store the value for that record. Be very, very clear. The return will be for that record. Okay. So now, if you have 1 million records, then obviously it has to go through 1 million iterations, right? So that is as simple as that. So this is how we will create a UDF and we will call the UDF, right? So simply let us understand how we can create a JavaScript based UDF, right? So here, if you see, I have a UDF called reverse string, right? It is also a same syntax: create or replace a function and the function name and input parameters, output a type, okay, output a type, and then language, and then the logic. Okay, so now I have already created this UDF. I have already created this UDF. Let us try to understand how it will how we can call this UDF, right? So here under the data set, I have reverse string. Okay, for this reverse string, I'm just passing my input column. Okay, so when you execute it, right? So your JavaScript based UDF also got executed and it has returned your string, right? So this is how we will create UDFs in normal SQL and also in JavaScript, right? So you can also use uh, functions on select statements, right? So you can create your select statements inside the UDF function, right? So that you can explore. You'll get that very easily. But I'm trying to show you there is a UDF concept, and by using which we can create and run UDFs, right? So in place of length into width, we also can use select statements. Okay, we also can use select statements. So here, if you see, here we just simply executed a length into width uh, multiplication, right? So you can go for select statements also. You can go for select statements also. So I request you to do that exploration and write at least one UDF using the select statements, okay, so that you will get some understanding. Okay, so that is about the UDF. So we'll see one more little bit use case. So wherein see here, I'm trying to create a table called URLs. Okay, that's my table name, and the table have one column called URL, and I'm trying to insert the data into it. Okay, so when I try to create this, so it will try to create the table. And what is the logic that I have given? I'm just taking select some URL union all, and then select another URL, so that it will try to create the table with a column called URL. Okay, so now let us see whether our data got inserted or not. Okay, see here, I have my data uh, in my table, okay, which is actually the URLs data, and I want to write a UDF. I want to write a UDF to identify the domain from the URL, right? So here, if you see, I'm just creating a simple function which will top level domain. So which is to extract the top level domain, which is whether it's a .com or .uk, .india, .us kind of, right? So I want to do that segregation on top level domain. So I'm just creating this function. If you see, inside the function, I have the logic wherein I'm matching with respect to a regular expression, right? So and then I'm just returning it. Uh, okay, and this is a JavaScript based logic. Okay, so I'm just executing this. Okay, so it's a illegal escape sequence. It is saying illegal escape sequence. So where is this? I think there is something wrong with this escape. Okay, so let's try it out now. Okay, so it is getting created. So this is actually created a UDF called extract TLD, top level domain. Okay, now let's simply call our UDF by specifying the column name. Select star comma from this table, and here what I'm doing, I'm just trying to call my UDF data set dot. So what is the UDF name, which is extract underscore TLD. Okay, and this is the UDF name. So here if you see, after this I'm just passing my URL column, right? So I need to pass my URL column. So URL is the column name. Okay, so to this UDF I'm passing my URL column. So now let's see how I'll get my TLD, right? Unclosed identifier literal, where is it? Okay, so here. Okay, so I'm just aliasing it as TLD top level domain. So I'm just running it. Okay, see here. So it was able to identify your top level domain, right? So I want you to practice more on these UDFs, guys. So I have shown you some sample UDFs, how to create the UDF, how to call the UDF. Okay, so and the advantages of UDF would be, so the logic or the custom requirement that you are not able to achieve with SQL inbuilt functions, that can be achieved through UDFs. So remember, when you are using UDFs, so there will be a performance hit. Okay, you should write your logic in such a way that you can as much as possible try to reduce your iterations or loopings, or use all the optimization things that are needed, right? So that is something about UDFs. Any questions or queries here? Any questions, guys? Everybody able to understand what is UDF?
Yeah,
Yeah. Prakati, Ranganath, are you able to understand?
Yes, sir.
Okay, okay, fine. So let us quickly go to the concept of views, right? So let us go to the concept of views. So in real time, uh, in traditional or normal data warehousing concepts, right? So we have a concept called views. Okay, so what are views, right? So let us quickly understand what are views. So views are the virtual tables, right? Okay, views are the virtual tables. So what do I mean by that? Now let us quickly understand that, right? So here you have a table, right? Table 1. Now you want to serve this table to the downstream, right? You want to serve this table to the downstream. So now the downstream may be the downstream may be a data science team member, okay, and the downstream may be some other application end users, okay, okay. So whoever it may be, there may be a reporting teams also who will be accessing this table, right? So reporting or visualization teams. So now assume these are different teams. You don't know who will be accessing this table, but you will be serving this table to multiple different teams. Okay. So when this is the case, we cannot give directly access to this table to all the users. Be very clear. We don't know, someone may come to here and do changes to this production table, and which will impact all the uh, data integrity quality, right? So, and someone comes, if simply delete the table, right? So what happens? So it will impact a lot, right? So for that reason, what we do is we build another layer, okay, on top of the target tables. Okay, once the data loading, once the processing completed, once we load the data into the target layer, on top of the target layer, what we do, we build the aggregated view layer. Okay, this aggregated view layer is, or view layer, simply aggregations may or may not happen in views. Okay, this view layer will be given access to all the teams. Okay, so what is a view specifically? So in SQL, when we create a view, right? So it is a virtual table. Virtually, it is a replica to the table, but physically the data will be there in the table itself. But v- through view also, you can access your table. Okay, so what do I mean by that? Now let's quickly see an example, right? So let us take an example of one table that we have. Okay, so now see here, I have a table called uh, stage EMP data, right? So select star from stage underscore EMP data, and it is in which database? EMPDB. Okay, so now when I run this query, I have, it's not found in local US. What is this?
I think table name.
Oh, yeah, STG. Okay, STG underscore EMP data. So when I run this query, I have this particular data, right? So I have lot of data, which is ID, first name, last name, email, gender, and IP address, and then created date, right? So now simply I want to see how many male employees or how many male IDs and how many female IDs are there in my table, and that data should be accessed by the end user. Okay, so the end user requirement is he want to see the gender, okay, gender, and count total underscore number. Okay, so how many members are there under each gender? So this is the requirement. Now to serve this, what we do, we'll just create a view, create or replace view. Okay, so create or replace view will do, and then you can, one second, let me see the definition. Yeah. Okay, so let's here create or replace view. So as, okay, so dev de, just 1 minute, guys. Okay. So here, if you see, I'm trying to create a view, guys. So dev d training dot under which uh, dataset empdb. So I'm just trying to create uh, aggregate underscore gender. Okay. So this is my view name. Okay, this is my view name, and then how we will write the logic for this view, as we will give. Okay, as, so select gender. Okay, select gender, comma, count of id. Okay, from from. So what is the table name? The table name is stg from empdb dot stg underscore emp data. Okay, group by gender. Okay, so this. Okay, okay, so maybe this is because of this statement. So I'll simply comment it. So to comment, we'll use two hyphens, guys, in SQL. So in Python, we use hash, right? So simply that in the similar way in SQL, we'll use two hyphens to comment any SQL line. Okay, so here I'm just trying to create a aggregated view layer, and the logic for that view is select gender, count of ID, and dataset table name, group by gender, right? So now when we do this, what will happen internally? It will create a virtual table, right? So okay, so 1 second. So total underscore cnt. Okay, now, so the thing that I want to tell you is views are virtual, meaning, so virtually this aggregate gender is a table. Okay, it will create that virtual table, but it won't have any data storage. There won't be any data stored in that aggregate gender table or aggregate gender view. Okay, internally the request will be pointed to the physical table. Be very very clear. When we try to call this aggregate gender view, okay, when we try to query this view, what will happen? That query will internally go and search the data in this table. Okay, as and when we query, okay, as and when we apply the query, okay, as and when it will apply, as and when we apply the query, on the fly the logic will be executed on this table, and that will be accessed via this virtual table. Okay, so that is the concept of views. Okay, that is the concept of views. Okay, so you need to understand that concept very clearly. So views are virtual, they are not physical. Be very very clear. The physical will be the schema of the view, that's it. The physical will be the metadata of that view, will be the physical. So it will store the metadata of the view and the logic of that view, but the data it won't store immediately. Okay, what it will do, when you run a query, or when you call that view, in that specific time it will go and hit the physical data store, which is actually our table. Okay, table is the physical entity, and then execute the logic on the fly, and then load the data to the view. Okay, so on the fly it will execute and then get the data from the physical layer. Okay, now why we need it, as I've discussed in the beginning, so we cannot give direct access to everybody in the teams to the physical layer, because they can change anything in the physical layer anytime, right? So which will impact the production line. So that is why we always create views in a separate data set. Okay, for specific to views we'll create a data set. Okay, for specific to raw layer we'll create a data set. For specific to target layer we'll create a data set. Okay, or else we'll create single data set and we'll maintain the naming conventions, the stage underscore table, target underscore table, and then view underscore right, something like that. We'll maintain the naming convention. Okay, it depends on the architecture. Okay, so now what we have done, we have created the view, and when we try to query that view, right, so this is querying the data when you call the view. This is querying the data when you call the view, right? So but this will reduce the performance. Let us take an example. I'm executing the same query, aggregate underscore gender, sorry, I'm executing the same logic, or I'm calling the same view 100 times a day. Okay, 100 times a day from the API. Okay, now your view will be executing the data on the fly, and all the 100 times that I'm querying will go with the same query time. Correct? Let us take an example. This for a million records, this query to execute, it took around 15 minutes. Right? Now for all the 100 times, this 15 minutes are common, right? So because it has to go to the physical layer, it has to execute the query, and then it has to return the data. So 100 into 15. So how much time it is? So it is taking on a overall, it will take a lot of time, right? So that's the reason when you are creating views in BigQuery, BigQuery has a special feature called materialized views. Okay. Materialized views are physical, equal to the physical table. Okay. But as and when the new data comes into the actual table, this views also will gets refreshed automatically. Okay, this views also will gets refreshed automatically, and this materialized views can be used for the pre-aggregated results, meaning you don't need to uh, run your query on the fly every time. Internally, what BigQuery will do is BigQuery will do the periodical refresh of this view continuously. Okay, as and when the new data comes into the actual table, it will automatically refresh this view, materialized view. Okay, now what will happen? For the first time when you execute the query, it may take 15 minutes, but from the next time what will happen, it will be pretty much faster, because the results are already aggregated and computed and stored in the materialized view. Okay, so that is the reason materialized views can improvise the performance. Okay, so here if you see, I have created I will create a materialized view. I already created, I guess. See here, I have a table called campaign data. Okay, I have a table called campaign data, and if you go to the preview, I have data like this: campaign ID, event date, event type, and then clicks, impressions, conversions. Okay, now campaign metrics is the materialized view. Okay, campaign metrics is the materialized view. So this materialized view, if you go into the details, so it is doing the aggregation. See here, it is doing the aggregation. Now campaign ID, date, sum of clicks, sum of impressions, sum of conversions, and then group by campaign ID and day. Okay, and this is a real time dashboard. Let us assume this view, uh, campaign matrix view, you can connect to a real time dashboard. Okay, so that it can refresh automatically. Okay, the view that we have seen in the beginning, it is quite time consuming, right? Because every time it has to go and execute this logic. But in case of materialized views, right, what will happen, it will execute this query once, and then it will compute the results and place it in the materialized view. Physically it will store. Okay, and as and when the incremental data comes in, the new data is coming into the actual physical layer, campaign data, then immediately what will happen, BigQuery will trigger this materialized view refresh. So then it will refresh automatically. Okay, you don't need to call or you don't need to execute the logic on the fly every time on the physical table. Okay, it will be pre-computed and stored in the materialized view periodically by BigQuery. So that is why materialized views are more optimized. And remember, these views are pretty much costly compared to the normal views. Okay, so fine. So anybody have any questions, guys?
So, is this materialized view suitable for a frequently updated table?
Yes, I mean frequent when you have data that is continuously updating in a physical table. Okay, on that table you can go ahead and create a materialized view with proper aggregations that you need. Then that materialized view, it won't need to execute your logic all the time continuously. So it can pre-compute the results for you whenever you call the materialized view. The results will, by that time the results will be pre-computed and stored in the materialized view. Okay, if it is a normal view, what will happen when you call that view, then it will go and execute the query on the physical table. But if it is a materialized view, the results will be pre-computed and stored physically, persisted physically in the materialized view. So you don't need to execute the logic on the view. Your request doesn't need to wait for the response of the queries, because the response will be very fast, because the data is already there in the materialized view. The pre-computed data is already there in the materialized view. Clear? Yeah. So if you see here, so I'm just calling my materialized view. So how we will create the materialized view? It is simple. We'll just add this materialized in the materialized or realized. Let me see. Okay, we'll be getting these details also, right? So if a view is a materialized or not, you can go and see the details here. So materialized. Okay, so I can. Okay, so I can create the materialized view simply like this. Maybe because already it is there, so I'm just creating it with another name. Okay, so I'm trying to create this materialized view, and I have created that view. If you see, that means this query results are pre-aggregated and stored in this materialized view. So if I simply go and execute this query, so what will happen? So it will go and call the materialized view, and it will try to give you the results. Okay, it will try to give you the results. So this is how you will create the materialized views and use them. Okay, fine. So any questions or queries, guys? Any questions?
Yes. In
Yeah.
real time, maximum we will use materialized views only, no?
It depends.
Performance wise.
Yeah, performance wise, we can use materialized views, Ranganath. But for example, my dashboard is a batch dashboard. Okay, and it is okay to my dashboard if it loads in a minute or 2 minutes. Okay, then in that case, every day I want to refresh my dashboard. In that case, you can go for normal views only. But not always we use materialized views, wherein the refresh time is very less, right? So the dashboard refresh time is very less, and we have to refresh the dashboard more frequently. Then in that case, we will try to go for materialized views, because using these views are a little bit costly. The storage will be aligned again, right? Assigned again. So that is the reason. Wherever the dashboard refresh frequency is very less and multiple times we need to refresh our dashboard, in that scenario we will go for this materialized views, Ranganath.
Okay.
Yeah. Anybody have any other questions? Please ask, guys. Okay, fine then. Hope everything is clear. Please go ahead and practice these UDFs and materialized views. Take some good data set, guys, 1 GB 2 GB data sets, and do some aggregations, right? So in that case you will try to identify actual difference. Okay, here 1 2 records we are taking, and I'm just guiding you to the concepts, that's it. Okay, so practicing is your job. You have to do the practice with uh, 1 GB 2 GB data sets. You can download that data sets from the internet, and you can try to load that from the UI. Also you can create a table. How many of you know, how many of you tried at least creating a table from the UI in BigQuery? Did anybody tried?
Mm.
Did anybody tried creating a table from
No.
see here? You can load the data. You can create the table from the UI itself. I don't explain, but I want you to try. Okay, you can create very simply the table from the UI. Okay, so try to use your smart uh, chat GPT way of practicing, guys. Do not waste your time in creating DDLs or creating things, right? Load statements and all. No. Okay, try to use your chat GPT and prepare your statements, write your stored procedures, and then keep them with you in the project. Okay, and that's all I have, guys. I was left with only one concept called common table expressions, CTEs, which BigQuery will support. Okay, so we'll discuss that on I think tomorrow we will discuss that part, common table expressions, and then we will proceed with the data proc. Okay, so that's the plan. Thank you so much for joining once again tomorrow. Yeah.
Yeah.
Thanks.